Jesse here with Evolve Sound Solutions. Today we're working on a pair of JBL 2412H 1-inch screw-on compression drivers out of the JBL JRX series of cabinets. They come in the JBL JRX 112, 115, and 215. I believe those are the model numbers. This is a 1-inch titanium compression driver. I believe I know what is failed here. This diaphragm is not producing any sound. I'm going to attempt to fix the diaphragm itself just for testing. And the particular cabs, we're actually going to go ahead and upgrade to this driver here. There's quite a difference in the two drivers here. And I'll go ahead and make sure to make a video when we do go ahead and put the PRV D2080 Ti in the top of those cabs. I'd like to get this pair of tweeters working so I can do a before and after comparison of the loudspeakers. So if I'm not mistaken, these are not original diaphragms. This would be like a Simply Speaker diaphragm or something, an aftermarket. And I could be mistaken. This particular diaphragm, the voice coil wire, runs right down and out into the terminal. Now, there's some burn spots on these wires, and my assumption is since they're not in the magnetic gap, they're getting hotter than the rest of the voice coil when driven hard. So I'm going to attempt to repair this. It's not going to be used permanently or anything, but we'll see my handyman work and see if I can get it going. So just to verify, we'll go ahead and drop that back in there and get the frequency generator out. This is the working one here, and then this is the other one here. See if I can make sure I get a good contact. Oh, pretty good contact there. Not too worried about these. These only going to be used for parts. There's nothing here yet. But anyway, in a minute you'll see that there won't be. Because we're going to go ahead and take this guy right apart. Now I'm going to start working off the cardboard here. Up to the diaphragm. Alright, now we're going to come back around on this side, same thing. Just working up the cardboard. And if you look carefully, you can see the tensile lead. Well, it's not really a tensile lead, it is the actual the wire there. I'm looking for any burnt spots as we go. The other wire is disconnected, so it's possible that this wire has burnt too. I can physically pull it off very slowly and look for the mechanical damage. Oh, it might have been right there. Might have found it right there already. So what I'm going to do is scrape this wire here a little bit. I'm going to do a dab of solder on there, just a hair, on this side, just to tint that wire and see if I can't get some conductivity for that. It's not liking me. But that should be enough to test what we need to test. So now I'm going to take some of my magnet wire here. Let me know in the comments section if you guys like me to take some of this wire here and wrap my own voice coil for a mid-range speaker. I have done that in the past for speakers I can't find replacement parts for. If you guys would like to see that done, let me know and I'll make a video of it. I'll take the wire here, and this is enamel coated wire, so we're going to take the coating off. This is of a thicker diameter than the original wire that's used as a tensile lead. And when I say tensile lead, I refer to the wire that connects the terminals to the voice coil. Alright, so now I tinted the end of that. There you go, you can see that there. I'm going to attach that to the other cable here. Attached because it's physically attached. I can see that. On the small stuff, sometimes it helps just to see if it physically attaches. Now I'm going to heat this up a little bit here and solder and break the enamel coating with the heat of the soldering iron. And then I'm going to solder him down onto this pad. And we're going to try to see if we can get him back going again real quick. This is not used permanently. I probably will buy replacement diaphragms for these later and recone these back to OEM. We'll get the frequency tester out here and see if we can't get some sound coming out now. No, still not yet. No problem. Oh man. Nope, not all hope's lost. Not worried about it. We'll go up the rest of the way and try it from there. So, for the sake of this, we're going to go take this off here. Alright, we got that peeled back. Peel that back as well. And they got some Kapton tape there. Let me see if I can find if there's a split in this wire. This looks pretty thin there. I don't think it's a split. That could be carbonized, so we'll pull this tape up some more. See if I can't get a little closer into the voice coil before I make a connection. Alright. So I'm going to go ahead and cut out these two old tensile leads that are in there. Probably see that. And we'll desolder the other lead that I soldered on originally. I'm just trying to figure out where I'd like to cut this at. Probably right after the metal. Take this soldering iron and remove that. Now we have our two tensile leads. You can see them coming off there. And they're stuck in the Kapton tape there. So I'm going to open the Kapton tape by making two slits parallel to the wire right next to it. I bend my scissors back in shape. One slit and another one here. Okay. That wire looks like it's broken inside there. So I'm going to pull this back a little bit on this side and see if I can't get better access to this one. Oh yeah, it snapped off right there. Okay, that's a bad spot. Found the bad spot. So now I'm prepping this area. For where I can solder onto. Soldering iron over here. At the same time, when I melt the glue surrounding this wire, I kind of try to pick the wire up a little bit, get it off the work surface there, so I can work with it free floating. I'll show you what I mean in a second. This is a pretty hefty wire here. The enamel coating's not coming off too easy, which is okay. I like to try to take it off with heat on the small wire, opposed to mechanically, because sometimes when you take it off mechanically, you take off a little bit of the copper, and that's all that's allowing it to function. I'm going to take our, okay, maybe we can see that in there. You cannot see the wires coming up. But we can if I go ahead and get our little microscope out. Let me find him. He fell. Microscope's, oh there it is. Microscope is mission in action. Okay. See if we can see what we can see. See if I can get a better shot on that voice coil wire. There's one of our tensile leads right there. See if I can hold that more still. For comparison, I'm going to put the screwdriver up next to it. And there's our wire right there. And that's the tip of a screwdriver. So what we're working with is very small. There's one of the leads. Let me see if I can get even better angle. Can you see it from here? There it is, the one with a little bit of silver solder on the end there. That's what we're working with. We have two of those. Let me flip you back over to the main screen here. I'm going to take our enamel wire that we prepped, or I'm going to prep rather. Prep the end with some solder to break the enamel coating. I say break to remove it, however you like to word it. Cool. Works for me. I'm not picky. If you're following along, you have an idea. If you're following along, you probably have an idea of what I'm doing. So if I use the improper terminology, it's still probably applicable. You still probably can understand. Bend this lead how I want it. Drop the iron down on there and heat that up. It did not bond yet. No problem. We'll work it again. If not, we'll get the micro iron out. Okay, I got a good bond there, so we'll put that down. Bring the wire over to the terminal. Alright. Now we'll go ahead and trim this lead here. Move to the next one.